morning, students. Today class we are going to discussing about AM transmitters. This is the fourth unit in analog communication system subject. In fourth unit we are mainly discussing about transmitters, in this fourth unit, we are mainly discussing the AM transmitters and receivers. What are the transmitters we are having and what are the receivers we are able to discussing in this unit we are discussing today class. First of all, we are saying that in fourth unit syllabus, we are mainly discussing about the transmitters. In transmitter, what is the classification of radio transmitters, and then what are the receivers we are having. Coming to the radio transmitters. The radio transmitters we are mainly classifying to two types based on the what are the parameters we are using them. Here we have to give the classifications based on different parameters like a frequency parameter and a modulation technique and broadcasting things. We are able to classify the transmitters in different ways. Here can take the modulation technique. Based on the modulation, the transmitters we are mainly classifying to AM transmitters, otherwise you can call amplitude modulation transmitters, and second one is frequency modulation transmitters, and third one is phase modulation transmitters. These three classifications is done based on the modulation. Based on the modulation technique, we are mainly classifying the transmitters are mainly three types. One is a amplitude modulation transmitters, and second one is frequency modulation transmitter, and third one is phase modulation transmitter. Now we are seeing that the first topic in this classification, that is AM transmitters. AM transmitter. First of all, you can see that what is the structure we are having in that. And this unit is completely, the discussion is going on transmitters. What is a transmitter and what is a receiver? Coming to the communication system. In communication system, we are having source. The source is connecting to the transmitter. The transmitter will be sending the data in wireless communication. Otherwise, you can take the wire communication. In wire communication, there is no need of any antennas. In wireless communication, only you have to using the antennas. Here you can use the transmitters and receivers. What are the channel you have to use? What are the communication system you have to using here? We are using the fundamental blocks is first we have to take the source. Which information you need to deliver to the destination. The source is delivering the message to the transmitter. The transmitter is connecting to the channel. The channel at second side is connecting to the receiver. The receiver will connecting to the what are the destination point we are having here. Then I am connecting to the loudspeaker. This is a fundamental structure of any communication system. In communication system, we are taking that source, what are the message you can deliver to the destination, that one we are calling the source parameter. The source is connected to the transmitter block. The transmitter work is what are the information it is collecting at the input side, that information can be able to deliver either in wireless communication or wire communication. This one is a channel. The channel either wire or wireless. After in this channel the information is traveling and then it will be reaching to the receiver point. After traveling off the information in this channel, it will be reach the destination point. That one is collecting by the receiver unit. The receiver will collect the information. What the information is available in that channel. That information is connecting to the our output device. It's a loudspeaker. In any communication system, you have to take these. These are the fundamental blocks. If you have to use in the wire communication, the channel is a wire. The channel is a wire. We are using the different type of wires like copper wire. The copper wire we are using a telecommunication system, and in normal telegraphic system also we are using these copper wires and optical cables. In optical communication we are using the channel is the fibers. The fiber is completely manufacturing. The manufacturers channels we are using is the fiber materials. The glass materials we are using in optical communication. These are the mainly using in wire communication. In wireless communication, you are using antennas, transmitter and a receiver. These two are relating to wire communication. And the antennas we are mainly using in wireless communication. Wireless communication. Now you can see what are the difficulties we are identifying in wire communication as well as wireless communication. Now see here, the wire communication and wireless communication. The first one is in wire communication, the installation time. The installation time in wire communication is more. Here you can take the parameter C's. Installation. Installation, cost and time. How the installation cost and time is varying in this wire communication as well as wireless communication. Coming to the wire communication, in wire communication you need to establish the wire between the source to destination from one point to another point. If in far distances and if a hill stations is there, after logging this establishment or installation of a wire, it is a very difficulty and costly. That's why the cost is more in wire communication. In wireless communication, just we are placing the antennas in certain ranges. That's why I have to take that zones Based on the zonal areas, how to design the antennas. Based on its directivities, we are launching the transmitter antenna as well as receiver antenna. The combination we are calling it transducers, the transreceivers. The combination of a transmitter and receiver we are calling it transreceivers. The transreceivers we are able to launch in a particular areas. It will be entirely covering by that signal. In that, the cost is very less in wireless communication. Coming to the time of installation in a wire communication is very more. Due to its launching and we have to establish the wire from one place to another place, it's take the more time. Suppose I have to launch this entire things, if any floods and disasters will be appear, entire what are the installation you have to done, the entire it will be damaged. Then you have to reinstall that, it can take the more time. For that, we can simply say in wire communication, there is a lot of time it can be taken the reinstallment or installation of the communication channel. Coming to the wireless communication. In wireless communication, there is no need to take that the media is a wire. Just you have to launch the antennas. You have to place the antennas in the position of wire. But you don't take the complete installation of wire. Just you have to place it at one point. You have to take some surface, some zone area in this surface. It is covering by some of the antennas. Like this. Here this antenna is covering this area, this complete area, and this one is covering this area. Just we have to place in that the antennas, what are the suitable antennas, like in the aspects of directivity and the radiation and its how much of distance it can able to cover. Based on that limitations only, have to launching these antennas, and then you have to easily provide in the wireless communication. Now, in that the time taking is very less can compare to wire communication. Coming to the remaining aspects. And cost time we are comparing here, and the remaining there is a chance to leakage, noise, and accuracy, authentication. Leakage. Here the information is losing in wire communication when the wire is a breaker. But the same difficulty we are also facing, the antennas will be damaged due to the sparks due to the sparks will be appear in the time of rainy seasons. But what the reinstallation process is there, in that we can easily reinstall and we can easily replacing that antennas, we can provide the better service for that. But in wire communication, we can identify where the damage will be there. Can identify that and we have to give that solution. It is very difficult. For that, the leakage identification is more difficult in this wire communication. But in wireless communication, you can easily identify and you can take the less time. You can re-establishment of what are the problem is existing in wireless communication. Coming to the next parameter, noise. The noise in wire communication. Suppose you can take the wire is a copper wire. Due to the internal passing of electrical signal, the electrical signal can be generating some internal noise. The noise will be used that the what are the message you have to deliver, it will be taken. Suppose you can talking to another person on your phone. It's a olden days it's a telephone system. We can unable to listen what he is telling. Why? Because it is taking some more noise. We can able to retrieve that it's a complete information. It is very difficult. It is only existing in when out using the copper bars. Suppose you can take in the optical cables. In optical cables, we are also getting the clarity of information and the speed of transmission. But launching of this optical fibers, it can take the more time. That's what we can simply say that the noise in this one is somewhat high when comparing to wireless. But in wireless also we are definitely not saying that the noise is less. Why? Because here the channel is A. The channel is A, we have to use it. But in this one we are using the channel is a wire. The channel or medium is a wire. In wireless you have to use the channel is in A you have to facing the different type of noises. The one is relating to the internal noise and second one is a external noise. Due to this two, we can able to getting that entire information is combinedly coming at the receiver with a combination of internal noise and external noise. That will be observed in wireless communication, but here also the noise is very high, but it will be removed by taking its alternative options. That's why the noise is very less in wireless communication. By using some type of techniques, we can filtering that noise. Coming to the accuracy. The accuracy of data we can mainly observe in wire communication, but in wireless communication we can farming that data. But data accuracy in optical fiber communication we can get the more effective. But in wireless communication is also giving that accuracy of data. Both are giving that data, but when you're taking that advancement in wire communication, it gives that good result. But in wireless communication also gives that the same amount of data with the less amount of cost. Coming to the last parameter, authentication. In wire communication, there is a difficulty due to the third party address. The third party persons is able to access when to making the conversation between any two persons. So those are able to taking that information. That means he is thefting that information. What are the conversation is done between one person to another person, the information he is able to listening and he is able to taking that. But it will be not possible in wireless communication. Why? Because we are writing encrypted information. It is also possible in that in wire communication, but you can effectively do it in wireless communication. Why? Because in far distances we can able to providing that the wireless communication. Why? Because it is high in the some hill stations and some forest areas. In that we can establishment of wire. It is very difficult. You can see that in defense sectors, in either military or any army or military or airport authorities, those are using the mainly is a wireless communication system. Why? Because certain frequency ranges are blocking that, but they are sending the confidential information from one place to another place. It's take the place of the credentials. Is my credentials is providing the more security from the different type of stealings. That is only possible in wireless communication. In wire communication also providing the type of authentication, but when out to doing that some precautions from that stealings. Coming to the topic, The next topic, the first topic in this unit is radio transmitters. The radio transmitters classification. The radio transmitters we are classifying based on the different parameters like modulation and frequency and coming to this fourth unit, the transmitters and receivers. So unit 4. On this unit 4 we are mainly discussing about transmitters and receivers. First one is the transmitters. In these transmitters we are mainly classifying radio transmitters. What is a transmitter, what it can do that, and what is the position of its in communication system. We are able to discussing that in this topic, and then we can give that what is the classification we are having in radio transmitters. The radio transmitters we are mainly classifying based on the different parameters, based on the modulation technique. The radio transmitters we are able to classify into mainly three types. One is AM transmitters, and the second one is FM transmitters, and third one is phase modulation. The phase modulation transmitters. Based on the modulation technique, we are able to classify the transmitters mainly three types. One is AM transmitters, second one is FM transmitters, and third one is phase modulation transmitters. Third one is a PM transmitters. This is one type of classification. And second one is based on the frequency. Based on the frequency, the radio transmitters we are classifying to low frequency transmitters, LF transmitters, high frequency transmitters, very high frequency transmitters, ultra high frequency transmitters. Based on the frequency parameter, the transmitters are classifying to mainly these types. Coming to the another parameter, based on the these two are the mainly classifications in radio transmitters classification. Coming to the receivers we are mainly classifying to AM receivers and FM receivers. AM receivers and FM receivers. And what are the fundamental blocks is existing in AM receivers, as well as what are the fundamental blocks is existing in FM FM receivers. We are able to discussing in these topics, and we are also seeing that what is the differences between AM receivers and FM receivers are able to discussing in this unit. And then what are the fundamental blockings like auto gain control, and what are the fundamental parameters can be influencing the receivers and transmitters also we are discussing in this unit. Coming to the transmitters, we are mainly having radio transmitters. The radio transmitters classification we have to studying here. Third one is based on the modulation, we are making the classifications AM transmitters, FM transmitters, PM transmitters. Based on the frequency parameters, we are able to classify the transmitters is low frequency transmitters, high frequency transmitters, very high frequency transmitters, and ultra frequency transmitters. Now we can discussing that first classification is AM transmitters. The AM transmitters mainly we are having in AM transmitters, we are classifying the mainly two types. One is a low level AM transmitters, and second one is say high level AM transmitters. AM transmitters we are mainly having two types. One is a low level AM transmitters and second one is high level AM transmitter. In low level AM transmitters we are mainly using for low frequency and high frequency, and also this one is used for short wave communication. Short wave communication also we are using the low level AM transmitters. The second category is relating to high level AM transmitters. For very high frequency and ultra high frequency ranges is using for high level AM transmitters. Now we are able to discussing about the low level AM transmitters. What are the building blocks in low level AM transmitters? Now we are discussing here. This is a fundamental block diagram of low level AM transmitter. Otherwise you can call the low level AM DSB-FC transmitter. In that is a fundamental block is RF carrier oscillator, buffer amplifier, and a carrier driver, and also giving that modulating signal source, band pass filter, pre-amplifier, modulating signal driver, and band pass filter. After that we are using linear intermediate power amplifier and a linear final is a power amplifier and band pass filter, coupling network, and these are mainly using in low level DSB-SC AM transmitter. DSB-SC means the double sideband suppressor carrier. Already we are discussing the double sideband suppressor carrier in previous topics. Now we are discussing that the low level AM DSB-FC transmitter. DSB-FC means a full carrier, and we are also on the suppressor carrier. Now we are discussing this. First of all, what we can doing here, which technique we are applying for in this transmitter. We are using the AM modulation technique, amplitude modulation technique. We can do this modulation technique. We must need that one is a strong signal and second one is a weak signal. The weak signal is always audio. That one is our source of information. The source we can take in that is a message, and strong signal is a carrier signal. The message signal we are calling a modulating signal. The modulating signal we can assign to band pass filter. The band pass filter can limiting the modulating source, and it can be assigning to pre-amplifier. The pre-amplifier can do that. What are the levels of your modulating signal is below its threshold, it can be boosting that its threshold value. By using this pre-amplifier, it can give that sufficient levels of modulating signal whenever doing the modulation technique. This signal can be assigned to modulating signal driver. The modulating signal driver can assign the signal to our modulator. This is one way you can assign the modulating signal to a modulator. And the second way is we can take the carrier. For carrier, we are having to consider RF carrier oscillator. The RF carrier oscillator will be generating the radio frequency carrier signal. Already know that oscillator means without any AC input, it will be produce the AC signal. It will generate the carrier signal in RF range. This signal is assigned to buffer amplifier. Why you can use the buffer amplifier means we can provide in the matching between carrier driver and carrier generator. We can provide in the matching between these two. We are using the buffer amplifier. The buffer amplifier it can use the proper matching between these two devices. Now you can take that output from the RF carrier oscillator. The value you can assign to buffer amplifier. The buffer amplifier it can be controlling any fluctuations in the generation of RF output. The signal can be balanced by using the buffer amplifier, but it can use that the efficient value of RF carrier oscillator. And if any leakage will be appear, we are losing that signal. But without leakage, we are mainly taking that buffer amplifier. The buffer amplifier output can be assigned to the carrier driver. The carrier driver it will be use this output to modulator. The modulator one is can take the one output from modulating signal driver and second output from carrier driver. By using these two, the modulator can do this modulation. The modulator can do the modulation. Here amplitude modulation you have to perform. Amplitude modulation. Amplitude modulation definition is already you know that one is the modulating signal is never change, but the carrier is changing. The carrier signal is changing its instantaneous values with respect to modulating signal at instantaneous time of its respect to values. You can simply remember the carrier signal, it can change its characteristics based on the modulating signal. That process we are calling the modulation. But here can call amplitude modulation. Which parameter is varying amplitude? The amplitude of a carrier signal is varying with respect to the instantaneous values of modulating signal. That is the definition of AM modulation. The modulator will generate the AM modulated signal. It will be assigned to the band pass filter. The band pass filter can limiting that signal. If any signal is less than its band, it can be attenuated. If the value is above its ranges, it is also be eliminated or neglected. The signal is assigned to the linear intermediate power amplifier. The linear intermediate power amplifier can use that the power is a linear increment. And then we are also assigned to linear final power amplifier. If the power is not sufficient, you can furtherly improve the power quantity by using the linear final power amplifier. This signal you can assign to the band pass filter. Once again you can limiting the signal based on our device. Then you can assign to the coupling network. The coupling network can use the proper matching between the bandpass filter and antenna. The output of coupling network, it is connecting to the antenna. Here the antenna, we are defining that the antenna is a metallic device. It can radiate and receive the signal from the atmosphere. It is a complete working structure of low level AM DSB FC transmitter. Coming to the second category, this is a high level. This is a high level DSB FC transmitter. In high level DSB FC transmitter, the circuit is like this. This is a circuit. In high level and low level, the main difference is in low level we don't use any power amplifier, but in high level we are mainly using the power amplifiers at ending stage. This is only the difference. Remaining blocks is as is. Now you can see here the blocks in high level DSB-FC transmitter, the modulating source, bandpass filter, the preamplifier, and a modulating signal driver, and a modulating signal power amplifier. The additional block you can compare it to low level and high level is only this power amplifier. The power amplifier is only the difference. And the same way you can able to assign the carrier signal. For carrier generation, you have to use the RF oscillator, buck amplifier, and you can assign it to carrier driver. After carrier driver, you can take in the carrier power amplifier. Here we can assign that the carrier power amplifier output to IM modulator, and the modulating signal power amplifier output also you have to send to the IM modulator, and output is a power amplifier. Just you can increasing that the output level. The output is power amplifier is assigned to the bandpass filter. It is assigned to the matching network. From this matching network to antenna. The blocks or building blocks is all are same, but here you can including the power amplifier stage each and every point. Each and every point means at before the modulator, the end stage of carrier, and the end stage of modulating signal, we are inserting the power amplifier. And also you are including the power amplifier in modulator. The output will be delivered to the antenna by using the matching network. The working is same. What are the working we are studying in low level, the same working we are studying in high level. But the change is, instead of normal amplifiers, we are using a power amplifiers. This is only the difference we can observe here. This is a complete classification of AM transmitters. Coming to the next category is the AM transmitters DSB-FC technique. Suppose you can take the SSB. By using the SSB technique, we are having the SSB pilot carrier and SSB normal transmitter. In that, how you can able to discussing the transmitter techniques. Coming to the next topic, SSB transmitter. What are the things we are discussing in this SSB transmitter? In SSB transmitter, we are having different types. In that, the popular one is SSB suppressor carrier transmitter. It is a bandpass filter is used to remove the other sidebands. In previous case, we are saying that DSB-FC. DSB-FC, it can take the more power. By using the SSB, we will minimize the power levels by reducing the sidebands. How you can remove that? Already studied in our previous sessions. Now we will see that block diagram. This is a block diagram. In this block diagram, whereas the main blocks is of any transmitter design we mainly using carrier and modulating signal. For carrier we are using a crystal oscillator, and modulating signal we are using the low frequency crystal oscillator. It is connecting to the two bands. One is a upper side band and second one is a lower side band. Which band you needed? That band only you have to connect here. But in case of DSB-FC, you have to use the two bands. But in the two bands, we are not effectively utilizing them. For that, the carrier is taking the more power. But here you can minimize the bands. And that the crystal, what are the modulating signal you have to take in that you have to make the separations in the form of the upper side bands, lower side bands. Based on our requirement only, we are making the separation. That is done if USB, the upper side band is needed, we can connect the USB to your low frequency crystal oscillator. Suppose you need a lower side band for your communication. We can select in that lower side band in your crystal. The upper side band and lower side band. Here I am connecting the upper side band to low frequency crystal oscillator. The output is connecting to the balance modulator. The balance modulator is taken from input is one is audio input and second one from crystal oscillator. But in this SSB transmitter, we are mainly using two balance modulators. One is a balance modulator and the second one is a balance mixer. But in case of DSB FC, we don't using this type of balance modulators. But here we are using two. One is a balance modulator and second one is a balance mixer. For here, we can minimize the power levels. We can split in the carrier to upper side band and lower side band. The upper side band is connecting to the low frequency crystal oscillator, and it is also taken the input from audio. These two is doing the balance of modulator, is making the AM modulation. The AM modulated signal is assigned to the side band pass filter. The side band pass filter is only allowing what are the band we are deciding here. Here I am deciding USB is the upper side band. Only the upper side band is allowing this one. And it can block the what are the components is below that value. And the value is assigned to balance mixer. The balance mixer is also taking the input from crystal oscillator. By adding these two, the output of side band pass filter and the output of crystal oscillator, that will be assigned to linear power amplifier. The linear power amplifier can improve the power levels of the balance mixer. Finally, it can assign to the matching network. The matching network is connecting to the antenna. Each and every block, it can play an important role in the transmission process. Suppose you can take any block, it is having some limitations. Based on the limitations only, we are mainly using in this block diagram. Coming to the next category, the phase shift method. The phase shift method in SSB is this one is a circuit. In phase shift method, just you have to apply the phase. The 90 phase, what happened? Without 90 phase, what happened? But what is the advantage? In SSB transmitter, we are using this phase shift method. By using the phase shift method, we can minimize the number of components. That means number of blocks we can minimizing by using the phase shift method. In this, In this one also we are using two balance modulators. One is a balance modulator 1 and the second one is a balance modulator 2. If you can apply the phase on a carrier, the same phase you can apply on modulating signal. Suppose you can apply the phase on carrier, the same phase you can apply on modulated signal. If you are applying on modulated signal, the same phase you can apply on carrier signal. These are done here. Now you can see the audio input. The audio input is, one is directly applying to balance modulator 1 and second one is applying 90 phase, then you can assign to the balance modulator 2. In phase shift method, the audio input I am directly applying to balance modulator and I have to assign 90 phase to the audio input, then I have to apply to the balance modulator 2. The same way can assign in the carrier. The first balance modulator can assign without phase. For second balance modulator can assign in the 90 phase. For first balance modulator directly taking the crystal oscillator output, and second balance modulator can assign the 90 phase shift to this crystal oscillator, then you can assign it to the second balance modulator. Now you can take the output of first one and second one, can make the summing. Make the summing of these two. And finally you can assign to the linear power amplifier. The linear power amplifier can boost in the normal values to higher values. Then this value is assigned to the margin network. The margin network is connected to the antenna. These are transmitter designed by using the phase shift method. Coming to the next type, that one is SSB transmitter with a pilot carrier. The SSB transmitter with the pilot carrier block diagram is this one. Why you can go for this one is it can give the more accurate values. You can compare it to mine to, and it is also reduce the power levels. That's what you can choose this. Coming to this one, here also you can take the audio input. The audio input is assigned to the balance modulator. The balance modulator is taken the carrier signal. The carrier signal, here you can fix in the whatever values it's needed. Particularly, the limitation values you can assign here. Suppose if you needed 100 kilohertz, we can take the 100 kilohertz carrier generation. Suppose you can need the 1 kilohertz carrier generation. 1 kilohertz is a very low frequency. Suppose you can take the 300 kilohertz. That particular frequency signal only you have to generating here. For that here I am generating 100 kilohertz carrier. This can be assigned to the balance modulator. The output of balance modulator are to assign to the upper sideband filter. The upper sideband filter, here I am assigning some limitation. What the values I am assigning here, in that values I am only taking the upper sideband quantities. In that also I have to give the range is 100 to 104 kilohertz. Within these values only it can allow the frequencies. Remaining all are it can be eliminated. This value is assigned to summing network, and also taken that the carrier insertion attenuator. Carrier insertion attenuator output we can add into here summing network. The summing network is assigned to the balancer modulator or mixer. It is also taken from another input from carrier oscillator with a frequency of 2900 kHz. These two values, the summing value as well as carrier oscillator frequency value, it can be mixing and it can be assigned to the band pass filter. The band pass filter output is assigned to the linear power amplifier, then it can be connected to the antenna. It will be radiating the signal to the atmosphere. Coming to the next pattern. Okay, the remaining things we are discussing in next class.